Okay, so I wanted to give you one more example of a hypothesis test with a proportion, one that is a little different in terms of the rejection region than the one we did in class, as well as a little bit different in the decision and the interpretation steps. So I'm looking at a problem from your practice homework in section 7.4, and what I'm going to do first is I'm going to write down my claim and then use that to determine my null and my alternative hypothesis. All right, so we can see right here the claim that we are being asked to test is that more than 26% of employees in this certain country have changed jobs in the past 4 years. So if I identify my claim that the proportion P is more than 26%, then I'm going to turn around and identify the opposite of that claim. Now, remember we talked about this in class. Only one of these two statements can contain equality. So if the claim has the equal to in it, the opposite cannot. But on the flip side of that, one of the two statements must contain equality. So if the claim is just greater than 0.26, the opposite is going to have to be less than or equal to. All right, one of the two statements must contain equality, and the reason for that is that we use equality to determine which one is the null hypothesis. So remember, the null hypothesis must always contain equality. So I'm going to take that less than or equal to, place it in my null hypothesis, and then the one with strict inequality, greater than 0.26, will become my alternative. So that means for this test, the claim that we're being asked to test is in the alternative hypothesis. All right, so now that I've done that first step, let's come on back over here and input that information. All right, the first thing we're asked to do here is just identify the claim in words. So the claim is that more than 26% of employees have changed jobs in the past 4 years. Now we used that to set up a null and an alternative hypothesis. So using the information we just went through, the null was less than or equal to 0.26. The alternative was greater than 0.26, and of course that was our claim. All right, so next I'm asked to get the critical values and the rejection region. So I'm going to come back over here. Because this is testing the proportion, I know proportion uses the standard normal distribution. So I'm going to look at my standard normal curve here. And I'm going to shade the rejection region. Now remember, to know where to shade, you always look at the alternative hypothesis. And because this one contains greater than, that tells you this is going to be a right-tailed hypothesis test. So that means I want to shade my rejection region here in the right tail of this standard normal curve. Now, what we use to determine the area of that rejection region is the level of significance for the test, right? That probability for error. So the level of significance for this test, which is the area of the shaded rejection region, is 10% or 0.10. Now, you've got to remember to use the standard normal table, you have to look up an area to the left of your value. So this is why for the two-tailed test we divided by 2 to make sure we were looking only at the left side. This is also why for a right-tailed test, when you go to your standard normal table, you have to remember to subtract that level of significance from 1 so that you are indeed looking at the area to the left and in turn get a positive critical value. All right, so what that means is when I go to my standard normal table, I'm going to be looking for an area to the left of 0.90 because that will in turn give me a positive z-score, and I know for a right-tailed test, the z-score has to be positive. All right, so I'm going to search the areas here, looking for an area of 0.90, and it looks like the closest I can get is 0.8997. So that's going to correspond to a z-score of 1.28. Now, just a little side note here. If you forget to do that, if you forget to subtract from 1, and you go to your table and you just look up the level of significance as is, what's going to happen is that's just going to give you a positive z-score. So if you were looking at 0.1, or I'm sorry, it's going to give you a negative z-score. So if you were looking at 0.1 and you forgot to subtract from 1, notice what would happen is it would show you a negative z-score. Same absolute value, but a negative z-score. And so the main thing here is you've got to remember for a right-tailed test that z-score has to be positive. So if I come in here and I look up 0.1 as is, and I see a negative 1.28, then I'm going to have to make sure I remember that for a right-tailed test, that critical value must be positive. All right, so that means this defining value right here, the critical value, is 1.28. All right, so again, I'm going to go back over here. I'm going to input that critical value, which again is positive because it is a right-tailed test, 1.28. And then my rejection region here, sometimes MyStatLab will have you identify the graph. Sometimes they'll just ask you what the region is. And then this is one of those cases where it's just asking you for the region. So just remember, look at what you've shaded. And what we shaded for a right-tailed test is greater than the critical value of 1.28. So that's just kind of taking that sketch, that graph that we drew, and writing it as an inequality. Okay, now from here, I need to calculate my standardized test statistic so that I can make my decision. All right, that is a formula. I'm going to take p hat, the sample proportion, subtract p, the value that we're testing, and divide by the standard error, which is p times q over n, all underneath the square root. All right, so I'm going to need some information from the sample. All right, I'm going to come back up here and look at what happened in my sample. All right, so we're told right here in a random sample of 260 people, so there's our sample size, 78 of them have changed jobs. Now notice that's not a percentage, right? That's a number of people. So that's going to be looked at as our number of successes. And so that means in this case, to get our point estimate p hat, we've got to take the number of people who fall into that category, divide it by the total. And here, that's going to give me a sample proportion of 0.3. So what I'm going to do now is I'm going to bring that point estimate for p hat. I'm going to plug that into my formula for the standardized test statistic. So that was 0.3. Now for p, I'm going to use the value that I'm testing, the value from the null hypothesis, which is a value of 0.26. And then I'm going to divide this by the standard error. Notice this is p, not p hat. So I'm going to take 0.26 times q, that is 1 minus p at 0.74, divided by my sample size, which again was 260. So when I calculate that here, I'm going to get a standardized test statistic of 1.47. All right, so coming back over here, my standardized test statistic, what I just calculated, is 1.47. And what I want to do with that is I want to determine if it's in the shaded rejection region. So if we take 1.47 over here to our shaded rejection region and compare, what we should see is that yes, it does fall in the shaded region. Right, 1.47 would be out here beyond 1.28. So because it is in the shaded region, which is our rejection region, that tells me my decision should be to reject the null hypothesis. Now, we talked a little bit about the interpretation step, and you do have to be careful about that one here because your claim is not actually the null. Your claim is the alternative. So you want to come back up here and you want to think about what that would mean if you were to reject the null hypothesis. Then by default, that means you support the alternative. So the way that I'm going to state my interpretation here, when I am able to reject, that means there is enough evidence, and I'm going to support my claim here because the claim falls in the alternative hypothesis. So again, what we said there is we are rejecting the null hypothesis. That's because we did fall inside the shaded rejection region. And because we rejected the null hypothesis, we were able to support the claim. Basically, we're saying, yes, that percentage is more than 26% because our claim fell in the alternative hypothesis.